All right, there we go. Now it's stopped, and we are live, and we are back. And it is Free Energy Friday, Real Science, episode 57, multi-streaming on Faraday Research as well, maybe WPG Enlighten for Truth. But we have Gerald back, got Mike, got Phil Bouchard, got Jeremiah. And Mike, I'm going to let you take it away a bit because you've got a lot to discuss tonight with coils and more.
Just FYI, I do have energy from the vacuum loaded for you, Mike, if you want me to play it. And Deborah Chung's negative resistance.
We'll talk about that in one sec. Before we get into that, I also have my channel running at Faraday Research. I call that show the League of Extraordinary Inventors. So I'll be doing more live stream videos. That. And we have a lot of people logging in. Got Mike there. We got Synthetic Future Entertainment. We got a lot of people logging in right now. That's great. We're going to talk about mainly tonight coils. And this lady I stumbled upon, I heard about her a while ago. I never really looked into her. Her name is Deborah Chung. And she developed this thing called the negative resistor. And Jeremiah actually found the actual video of one of her lectures, I guess, and we're gonna watch that because I think it's pretty significant what she came up with. Now, she did file for a patent around 1995, 1996, and then all of a sudden, poof, she disappeared, and nobody's really heard from her since. Did her project go black? Well, maybe. Maybe she was onto something that the powers to be did not want to get out. So we'll discuss that tonight. So we're going to talk about coils with Gerald. He's got some really cool stuff to share with us. We got Philip in Montreal tonight live with us. He's going to talk about the time dilation and clock experiments. And so we'll start right there. Maybe we'll play that video of Deborah Chung. And we'll get that out of the way, and then we can, start the discussion from there. You got that ready, Bernie?
It says it's loading, but then there we go, I believe.
Can you explain to me the meaning of energy from the vacuum? I don't want to make it imply that I am endorsing this particular concept.
But that will not be.
But I don't want it to be implied that I do that. Okay.
And we just want to talk about the phenomenology and the discussion.
Yeah. Okay.
No, we're not looking for your endorsement.
Yeah.
We just explore.
Okay. Fine. Okay. I've been in the field of material science for 30 years. I was educated first at California Institute of Technology, where I first got introduced into the subject of material science. However, at that time, my major was more in electrical engineering. But through research, I got very much interested in material science because it is so rich in science at the same time as practical, and I like that combination. So after graduation from California Institute of Technology, I moved on to Massachusetts Institute of Technology, or MIT, for my graduate work. And there, my focus was on material science. And in MIT, I got involved with carbon research for the first time. And that has been the focus of my research for the last 30 years. Carbon, referring to graphite, carbon fibers, carbon fiber composites, activated carbon, diamond, nanotubes, quite a large variety of materials, and a lot of applications involved. And I have been working on a large variety of properties of these various materials, not only the structural properties, but the functional properties, such as the electrical properties, how the electrical and the mechanical properties connect to one another, and also the properties related to electromagnetic fields and thermal applications. And carbon fibers are most important from a practical point of view because of the carbon fiber polymer matrix composites. The polymer matrix primarily epoxy. And that's, this is an example of the carbon fiber. It looks like hair, but it's just a very small fraction of the size of our hair. And it's all carbon. And it is very strong and stiff in this direction, but it's very light. And so it is very effective as a reinforcement. So one can embed these continuous fibers in a certain matrix, such as a polymer matrix, and after curing or letting the polymer solidify, one obtain a stiff composite like this. And this is what's widely used for aircraft structures because of their combination of lightweight, high strength, and high stiffness. And compared to steel, for instance, it is much, much lighter. And so for fuel saving in particular, this is very much used for aircraft. And nowadays, they are getting to be used more and more for automobiles as well. And also for tennis rackets and fishing rods. And so the structural side has been the prime application. However, because of my background in electrical side, I have been looking at the electrical behavior of this material, something which is kind of not ordinary because for structural material, people don't usually look at the electrical side. And by looking at the electrical side, I have been able to observe some very interesting phenomena. And in the electrical side, the behavior depends on the direction because, as you can see, the fibers are oriented. Okay, it's directional. So if you make a composite, then if, let's say, the fibers are lined up in this way, then the properties of this composite would be very different in the different directions. Not only are they different between this direction and that direction, they are also very different in the vertical direction because a laminate is really a stack of the fiber layers. Each fiber layer consists of thousands of fibers thick along the thickness of that fiber layer. And each fiber layer is called a ply or lamina. And you have all these plies stacked up, and then you consolidate them together under heat and pressure usually. Then one obtain a composite. And this is the vertical direction, what we call through thickness direction. And it is the electrical behavior of this through thickness direction which I have investigated a lot in, and that's the direction which has received very little prior attention because that's the direction perpendicular to the fiber layers. And I found this direction's electrical behavior to be very interesting. And the reason why this direction is interesting is that the electrical conduction in this direction hinges on the degree of touching between the fibers of one ply and the fibers of the next door ply. Okay? And one can control the extent of that touching by the fabrication condition of this laminate. For instance, by the curing pressure, heat and pressure, I said. Okay, so that pressure, so-called curing pressure, which is the pressure applied during the curing or the making of the composite, can greatly affect the extent of fiber-fiber contact between the fibers of one ply and the fibers of the next door ply. And because of that, the electrical conductivity in the through thickness direction can be much affected by the way this laminate is made. Okay. All right, so I have made a study of the electrical conduction behavior in this direction for different types of such laminate, these different types being different in the curing pressure. Okay, and so these different types are different in the extent of fiber-fiber contact across the layers. And I found different behavior, in systematic differences. That is how the conduction behavior correlates with the curing pressure. There is a very consistent correlation. So in order to study the electrical conduction behavior in the through thickness direction of the composite, that is in this direction, we take two plies, okay, and we made the plies so that we lay one on top of the other. So this is the top lamina or top ply. This is the bottom lamina or bottom lamina or bottom ply, 90 degrees, one over the other. Okay, and this is the junction, and we consolidate this junction. That is, make a composite out, a two-ply composite out of this junction, by applying heat and pressure. The pressure being the pressure in this direction perpendicular to the sheet of paper. And now the reason why we want to make it in this configuration is that these fiber groups sticking out act as electrical leads. So in this way, we are able to get current passing through this junction and measure the voltage across that junction. You just simply using these as electrical leads. Okay, and there are 4 electrical leads, which turn out to be very useful because we can use 2 of the leads, A and C in this case, for passing current, and use the other 2 leads, namely B and D, for measuring voltage. Okay, the current thus goes along this top layer, along this leg, and then it goes down in the direction perpendicular to the sheet of paper, from the top layer to the bottom layer. And then it goes on along this leg of the bottom layer. Okay, so that's the current path. Now, the carbon fibers are much, much more conductive than the polymer. In fact, the polymer can be considered to be electrically insulating. Okay, so for this current path, the major resistance is the resistance across the junction. Okay, and then the voltage is measured across B and D, and an ideal voltmeter has no current going through it, and so we can just assume no current going through these 2 legs. And because of there being no current, then the potential at B is essentially the same as the potential at the top of the junction. And the potential at D is essentially the same as the potential at the bottom of the junction. Okay, so in this way, the voltage difference between B and D gives the voltage across the junction. And the voltage divided by the current gives the resistance. Okay, and and this resistance reflects the contact resistance, which is the resistance across this interface. And this contact resistance multiplied by this junction's area, what's called the contact area, gives the contact resistivity, which is a geometry independent parameter that describes the nature of this interface.
I have a quick question.
Mhm.
The common interface area, and I may have missed it. Is there pressure applied to this, or is there glue, epoxy? I mean, or is it just laid on each?
Yeah, just laid on. Now, the epoxy is already surrounding the fibers. That is,
Oh, we got it paused there.
Sorry for the delay. I just jumped back in and paused it because this is a 40-minute video clip, and I just wanted to know if anyone would like me to jump ahead to the meat and potatoes of this presentation, where she really starts to talk about where this effect happens, specifically why, and where she shows the physical demonstration model.
Yeah, do it. Jump ahead.
Okay, great. Then I'm going to go do exactly that and mute myself out again. And just let me ask, was the audio coming through okay? Because on my end, it looks like it's being
pretty decent.
crushed.
It was okay. Yeah, at times it would go a little choppy,
but
not bad.
It was good.
All right, let me go ahead and try to just jump straight into the good stuff then, and we'll knock through this.
The resistance. Tendency for backflow, and that backflow in turn results in the apparent negative resistance.
Electrical characteristics of the composites.
Yeah, that's a good question.
Backflow and
I'm
negative
interested in the
resistance.
electrical side of a structural material.
Negative resistance would be acceleration, no?
I'm interested in making smart.
Actually, no energy coming into the system. If you add energy into the system, the resistance will be less.
Yeah, that's what I'm saying. Like, if it's negative, isn't that like a double negative that would equal a positive sort of thing?
Yeah, like superconductivity.
Well, energy is coming from the outside, but she's not exactly saying that for reasons, right?
Oh, right. So right there. So the laws of conversation say it has to be a closed system. So if there's more energy coming from the conservation. Sorry.
So let's take a look at the comparison just for the technical side. Positive resistance versus negative resistance. Here we go.
He's cranking up. So the top curve is the current, the bottom curve is the voltage, and he's cranking up the two. It's just manual cranking, so it's not very smooth. Nevertheless, one can plot the current versus voltage, and you see it's linear, positive slope.
Which is a completely standard.
Yes. Yeah.
Generic current voltage relationship.
Yes. All right.
And this is with material that has been cured at what pressure?
The relatively low pressure, which is around this 0.13 megapascal area.
So this is generic carbon composite cured material.
Well, all these are generic, just that I vary the curing pressure.
Exactly.
Yeah. All right. So now we proceed to the another such sample, but made with relatively high curing pressure.
Take note, everybody, the computer that they're using, that's like 1995.
No doubt, hey? Some old equipment.
Yeah. That PC is like circa 1995-ish.
The second sample.
Look at the monitor,
using the relatively high curing pressure.
Yeah, it's all tube monitor CRT.
We do exactly the same experiment, passing the current like this and measuring the voltage across these.
So this is an old suppressed discovery, is what you are saying.
Oh, she disappeared off the scene before it really caught traction until this video came out and people started looking into it again.
Well, she got contracted,
But,
and that's a huge part of the
yeah,
problem. So, like, here we're looking at 10 times the pressure. And at this point, what was a positive conventional resistance relationship, now she's about to show you where it really gets good. Because these are terminated carbon fiber filaments. I believe they were approximately 6 to 8K. This was before those kinds of ratings were actually quantified. But this is in the very, very early days. In fact, it's thanks to her work and the developments that lab did, where we now have carbon fiber bodies for extremely high-end performance vehicles. So way before all that, 10 times more pressure. It's approximately equal to a 1 inch by 1 inch cross-section strip experiencing 150 psi on a 1 inch square. So if you're looking for what to do in the garage, 150 psi, she starts to achieve the beginning of the curve for the negative resistance interaction region between carbon nanotube conductors. And let's take a look at that data.
2 legs. So let's do that now. All right. So he's cranking up the current manually again. And the top curve is the current, the bottom curve is the voltage. And you can see that while the current is cranked up, the voltage goes down. It goes negative. And so now you plot the current versus voltage. It is a straight line of negative slope. Okay. And this is what we call apparent negative resistance. Okay, now first of all, I'd like to explain that I don't think that this is true negative resistance. That's why I call it apparent negative resistance. And I believe that this phenomenon has to do with the electron flow having a backflow. That is, you have current electrons going from one layer to the next layer. Okay, and then there is a tendency for the electrons to flow backward, okay, from the one layer back to the first layer. And this backflow is driven by entropy. Okay, just like diffusion is driven by entropy. And because of this entropy-driven backflow, you have this backward current. And under certain situations, this backflow can appear to dominate. And when that happens, you have the apparent negative resistance. Okay. So I call it apparent because I believe that it's entropy-driven. Okay. A true negative resistance, which I'm not claiming, would have been driven by energy rather than driven by entropy.
Jeremiah, you gotta mute yourself, brother.
And
Oh,
then
you
the
just
charge
did.
would go towards the not the positive end of the voltage gradient, but the negative end. That would be true negative resistance, and that's driven by energy. Okay, but in this case, it's not driven by energy. I believe it's driven by entropy. Okay, and that entropy causes the tendency for backflow, and that backflow in turn results in the apparent negative resistance.
What led you to look at this particular set of parameters with these materials? What inspired you to look at the voltage and current characteristics? Or is this something that's particular to your field of work? As you had said, you focus on the electrical characteristics of the composites.
Yeah, that's a good question. I'm interested in the electrical side of a structural material, seemingly an odd thing. The reason for that is that I'm interested in making smart composites or multifunctional composites. I want to use the electrical behavior as an output or indicator so that the structural material becomes a sensor. Okay. So it could be a sensor of damage, sensor of deformation, sensor of temperature, whatnot. application is just to use this as an electrical device. An electrical device that exhibits this particular current voltage characteristic.
It is what it is.
Yes, it is what it is, and just use it as an electrical device. We can tailor it, and so you have a series of electrical devices.
Have you had inquiries in that regard? People interested in replicating it for application as an electrical device? Have people inquired to you about that at all?
Not a whole lot. Yeah. Oh, thank you.
Are you familiar with Chung's work?
Yes, the negative resistor that she built is absolutely for real.
Shout out
As far
Tom
as I can
Bearden.
see, somebody's put a clamp on that. Because they filed the patent and everything like that went fine. But all of a sudden, you notice a great silence, which means somebody is using it for some kind of a classified project. That's what it means. In my view, having been there in aerospace and know how they work, the work was being funded, as I understand, probably by agencies that would, in fact, do that.
I definitely got to be trying that.
So which one's that, Mike? Gerald or Jeremiah, do you mind me pausing?
Actually,
Thank you.
yeah, definitely we should try that experiment ourselves. It's not that hard to get a hold of the materials. And she said the applied pressure to the polymer in the carbon fiber was not that great. It's something you can actually do at home and put under pressure, let it cure. Make two strands, put it in the T formation.
So I've got all the stuff sitting here.
Yeah.
It didn't actually cost that much. It took almost 3 months from Alibaba. If you'd like to see, I can go ahead and show you on my webcam if you would like to see the stuff.
Do it up.
Sure.
Absolutely.
What would you have to use? A hydraulic press?
Nah, I wouldn't even bother. I just simply take one of my 1 inch by 1 inch square flattened pieces of metal, cubes, or rods. I'd sand the ends off so I had a very, very good and strong coherent junction. I'd sit there and I'd sand them on a wet piece of 1000 grit for approximately an hour straight. So I had a very, very flat face. Or I'd use an optical mirror, which is already known to be a very flat face. I'd take 2 of these strips, I'd lay them down on a piece of ceramic composite, and I would attach the ends with just simple tape. Then I would apply the epoxy over the top, place the weight on top, and I would pull a vacuum on the entire device for approximately 10 minutes, let it decure, let it degas, and then allow the pressure to release, ensuring that vacuum was surrounding the entire billet. At that point, I'd remove the billet, I'd replace a piece of plastic material designed specifically so that epoxy does not stick to it, and I'd wipe the billet off and place it on top of that piece of plastic so that I could easily peel it away when the whole thing was cured, and then I would let it sit for 24 hours. I know this was a whole lot of steps, but I tried to lay them out very clearly because this is the number of steps that it takes to actually make a very good junction between these types of materials. And of course, I'm sure there's a better way. This is the complicated way, but if you wanted to know how Deborah did it, it was something quite similar to what I've just described in great detail. So
I'd rather just find someone who made it and just buy it.
I'm sorry, I didn't hear that multiple voices at once. Can you just say again?
I said I'd rather find someone who made it and buy it. So I'm sorry, man.
I can't blame you either. If I could just flat out buy this stuff, I would. Unfortunately, all of Deborah's work and the entire string of discoveries that were made in her laboratory, well, they've all disappeared at this point. And ironically, if you wanted to know where I found out about this, I'll say it once and don't ask me again. WSF and M.
Ooh, that's interesting.
Okay, so I'm not
You know what?
even going to bother combing my hair. I'm just going to go pop on my webcam real quick and let me show you the CNT fiber. Okay, here it is. This is a 12K strand of CNT fiber. If we look at it from the side, at just the right angle, I mean, this stuff is so insanely thin, it practically disappears.
Yeah.
Anyways,
All about
12,000
perspective.
individual fibers. You cross 2 of these fibers, like this. You attach them to each other and epoxy them down.
Yep.
There is a junction jump between the two. And that junction jump is exactly what we were showing earlier, which is the epsilon. It makes the double loop in free space from one to the next. The double loop represents an extra electric field. It's a negative resistance field because there's actually a negative physical potential that you can measure with a probe between those 2 points. It shows up on the scope if you stick it close enough, or if you simply have a field probe attached through a dielectric, you'll see it charging like a capacitor until the thing disappears. And so it's a very simple effect to replicate. And again, this material is not very expensive. It just takes a long time to show up. And I'm not sure if they're still selling it. At this point, it's become increasingly difficult to purchase.
Well, you know what? I think it's time we kind of resurrect that a bit and start doing some testing with it. I think it's worth it. You know, it's not like you have to spend $1 million to reproduce what she did. As long as you get the processes done.
I mean, the stuff is very available to us. It's not unobtainium by any stretch of the imagination. These materials we can purchase if we don't mind waiting, and we now have several United States-based and Canada-based new manufacturing laboratories now getting into this brand new emerging field and producing, well, cutting-edge carbon fiber filaments using many different methods, some of which offer even better properties depending on if you're looking for a dot product or a cross product. In this case, we are looking for the interaction between the two, a cross product and a dot product. So this is a little bit different, but unfortunately, Deborah's work is not made publicly available except for that video that was, luckily for us all, archived somewhere on archive.org.
Yeah, exactly. I think what's also important too is, you know, how we can apply this device to what, say, what Gerald's working on, or even what I'm working on. You know, how would that react? You know, hooking that up in the same circuit with a coil and firing off that.
Dude, you've got to check out all the videos because every single question that you just asked, Gerald has already answered and addressed. And if the few that he has not, I have. So every single one of those, it's already been addressed. It's all up there. We just got to locate you the right links.
All right.
The future's so bright. I gotta wear shades. Sorry, I can't sing.
I can't help it either, man. Like, this is so exciting.
Right. Well, you know, some people are talented with singing. Others are talented with bringing ideas out of the ether and turning them into devices. And
well, singing is not my forte, I'll tell you that.
Well, that did not stop Daniel.
Yeah, you're not wrong.
Hey, Gerald, while we have you on, did you want to give us an update on what you've been doing the last week or so? Or
yeah, sure. Do you guys want to see a little video?
Oh, always. Yes, please.
I'm down for that for sure.
All right, let's see here. Do you have to share screen at all?
You might have to, yes, or we can enlarge your screen if you want to, like, play it and, like, off your phone onto the camera or something.
Okay, so I gotta hit present.
Yes, sir. Then the share screen.
Let's see if I got the right one here. All right, can you see that?
Oh, yeah. Look at them coils.
Okay, so this
Oh, I
is the
think I saw
700.
this.
Yeah, this is, well, you haven't seen this particular video, but you've seen this coil. This is the one that's in my my superconductor series, so to speak. So this is the 750 foot bifilar coil, and what I've got on the secondary is a hairpin circuit. And what I'm going to do is I'm going to light this beam. I don't know if you could see my mouse or not, but this is an
Yes, sir.
okay, so at the bottom of the screen here, this is an LED grow light beam. It's 150 watts, and I'm going to light it with 27 volts, 261 hertz, but I'm going to light it with 2.5% duty cycle, just at first. And it doesn't light up bright, but I'm going to incrementally go up from 2.5% duty cycle to 5%, then to 10%. And then I'll show you my max 50% duty cycle, and you'll see the difference. And watch the watt meter. So here we go. This is the 2.5%. And I'll bring up the watt meter so you see how much I'm drawing.
So to poke the tiger, a full illumination, 150 watts on this strip.
Go ahead. Yeah, 150 watts full. Right? But that's not full. It's about 20%, right? Lighting factor. But now I'm going to turn it on to 5% duty cycle, 261 hertz, 27 volts. And again, I'll show the watt meter. That's 5% duty cycle.
So just honest feedback, from the view that we are looking at, it looks like it's pretty darn dim.
It does. It's about 30% bright.
It looks much less from the camera view.
Yeah, the camera loves to correct, eh?
Just to let you know. Now that's starting to look like we're getting somewhere.
That is 10% duty cycle, and still no watts are showing up on the meter.
My eyes tell me that's approximately 20 watts of power.
It
If I
seems
had to
brighter
guess
in
at it.
person. It seems much brighter in person, I'll tell you. So this is the 50% I'm going to show you, and you're actually going to see watts on the watt meter. But this is a 50% duty
The
cycle right
current's
here.
being generated in the coil.
Yes, it is.
Yeah,
And that's
where the current's
50%
being
duty cycle.
generated.
That
You're
looks like
providing
about
AC
45
voltage.
watts to 50 watts. Oh, that's actually what it is.
Yep.
Okay.
That's
But
at
now
full
here's the
power.
thing. On camera, what you're seeing looks like about 45 watts, but I can't look at that light. It's blinding. And if I run it through its regular ballast, it's not much different. But now, again, I will show a video with the regular ballast. I don't have one keyed up, so I can't do it now. But I'll put it on my channel, and I'll show the comparison so that you can see. So then, like you said, maybe you can gauge. Maybe it's 50, maybe it's 40. Just by looking at the video, you might have a better chance of seeing that.
Yeah, this is one of those cases where a photon meter happened to be one of those necessary tools that both you and I would be using. Just look at the luminous output of an LED source.
Absolutely.
So
Okay,
we both have a little bit of work to do in terms of getting ourselves a calibrated source.
Yeah, there's a few tools that I could use to show a few things. Now, there's one other quick video I want to show. If that's possible. Let's see here. All right. Share screen. Okay, so let me back this up a little bit. So basically what I'm going to show here is It's the same experiment, but while I'm lighting the lights, what I'm going to do is show the movement of the magnets. And it's going to tip both ways. And all I'm doing is turning it on and then shutting it off. That's it. That's all I'm doing. And you can see how the magnet will move. So I crank it on really quick.
Oh.
And then I crank it on again.
FYI, we are not seeing your screen.
No, now it's up. Now it's
Oh,
up.
you're not seeing it?
Okay, so
I got it up now. I got it up. We're good.
Restart that whole thing
Okay.
from the beginning.
So again, I'll crank on the power for the lights. You'll see the lights come on bright. But watch the magnet, what it does. So it flipped to the right. Now I'm going to turn it on again. And it's going to flip to the left. Hard to see. So
did you invert the polarity to the input, or did you?
Nope.
Very interesting.
And then it inverts again the other way. And it's spinning. Yeah.
It should be symmetrically disposed. So if people think, well, it's on the right side versus the left side, realistically, that's supposed to be pretty much symmetrical as long as it's equally to the right as it is equally to the left.
Well, according to the ruler, it is. Now, I could be off a couple millimeters, not so sure. But as far as a rough experiment goes, I'd say it was pretty dead on.
But the coil generates a magnetic field?
It actually generates a magnetic vortex. And you can see it. I have it on multiple videos where the magnet starts spinning and then it follows the outside perimeter of the coil, just like a force field. And when you stick it on top, it will literally spin around the top of the coil.
Nice.
At first, I thought his table was tilted. The first time I seen the video of the magnet and what looked like it was rolling around the outside of the coil, I thought, well, the table is tilted. It would just take that path. And then my brain suddenly realized the table is tilted, perhaps, but it's not curved. Why is the magnet taking a curved path instead of simply a straight path?
Yeah. And it curves right around the coil. It's because the vortex that is produced on the inside of the open core of this coil is in the opposite direction as the vortex that's produced on the outside of the coil.
Crucial information right there.
It just seems to stick a little
So
too
you got a
perfectly in its
double-
exact equidistant spacing to the outside of the coil. It's like once it fixes in at 12 millimeters, it seems to stay exactly there during the entire rotation. And you've got an MDF table there. It's well known to be a pretty crappy surface, all full of imperfections and bumps and everything, which almost acts as if, well, that magnet is stuck somehow in a superposition and locked to that spacing.
Yeah, it's a countertop. It's the experiment's interesting. I'll say that. I'm gonna do a full presentation, hopefully very soon on APEC. Maybe in a while after, I don't know, we'll see. And I'm gonna explain everything in detail, like how it's built and then what it's based on. It's based on dichotron instability, basket winding, proximity effect, parasitic capacitance. It's the skin effect comes in to play big time, fractal design, and so does kinetic inductance. So these things that it's based on is what makes it work. Without any one of them, it wouldn't work at all.
Yeah, I would have never had that vision had you not taught me what you taught me. So
You're
would you
genius
say
in your own right, Jeremiah, by far.
So, Gerald,
if
would
it's
you
a
really
vortex-
say that?
So sorry, if it's a vortex, you could use it in a toroid.
Yeah.
Yeah.
Yep.
So you can make like a ferromagnetic fluid spin in a toroid.
Oh yeah, I'm pretty sure. I haven't done the fluid thing, but I use ferrite cores for pickup coils. That's how I get a lot of my energy out of the vortex itself.
Yeah, that's pretty useful. What you just
Hey,
did.
Gerald, would you?
Go ahead, Mike.
Would you say too that you're saying the skin effect? Would it be fair to say that the vortexes have a electrostatic property to it, not just electromagnetic property?
Oh, absolutely. In fact, electrostatics is part of how the skin effect works, because in between the two layers of copper, think of it like energy's flowing one way and then it's flowing the opposite way at the same time, and they're crossing paths. So it's creating like a static moment almost.
Yeah,
I'm not sure if I'm explaining that quite.
longitudinal. It'd be longitudinal because Tesla was saying that in between the longitudinal wave, there's electrostatic field. It's kind of like it's like a double. It surrounds the longitudinal wave itself.
If anybody would like, I can add to that in
Yep.
terms of the
Go ahead, Jeremiah.
So it's a relativistic amplification effect, and it has to do with the observer reference frame. So if you are calling an electron the observer, where it's positioned and its velocity relative to another electron, the way that the two electrons will see their fields is going to be entirely dependent on their velocity, acceleration, and angle to each other. Hence, angle makes a huge difference, and so does conductor free electron drift velocity. So it produces what Richard Van Duyck has lovingly titled a geometrically amplified relativistic field. And between the two, we've got our red and blue arrows, which is one of the things that I showed previously, just to kind of animate how what your coils are doing, Gerald, and the things that we've talked about. It gives a possible explanation. I'm not saying that it is the explanation, but this is basically what happens when we interpret the mathematics into a two-dimensional cross-section image between a set of 90 degrees conductors. And it's this image, the one that we've looked at before. So
it's a gyroscopic sphere.
Right. So our blue arrows are the nominal electric fields. They're symmetrical from the center position of a stationary electron, but the red arrows are occurring because at the bottom we see a blue vector acceleration arrow, and at the top we see that the blue vector arrow at the bottom is slightly beneath the red arrow, whereas the blue vector arrow at the top is just about overlapping the red vector arrow at the top, and the two on the sides, well, they're equal. So from the outside positions, it seems like our electron has a stronger electric field than it should otherwise have, because it's been experiencing acceleration and because it has relative velocity to the little purple electron or proton on the right side, and the one on the top gives us our other vector arrows. That's as in the blue and red axes arrows that are directly down from the top circle. They're what that circle sees in terms of the relativistic electric potentials. So this has everything to do with geometric amplified potentials, and it has to do with relativity and the Lorentz transform. Of course, we have to get rid of the gauge factors. The gauge factors remove the possibility of a physical epsilon and mu modification in free space and real warp drives. So if we account for that and integrate what is already in general relativity, we have a full picture.
Well, it's funny you say that too, because this coil doesn't just do what you're seeing or what I've been showing. It does a whole lot more. If you can control a vortex, an electrostatic electromagnetic vortex, and you could vary your electrostatics in comparison to your magnetics, right? I'm just saying this for layman's terms, so to speak. There is so much that you could do with this technology.
What is the
anyone who starts out at this is going to be writing encyclopedias about it. That's how much you can do. I'm not saying my coil. I'm saying this technology in general.
What RPM are you achieving? Do you know?
RPM? What do you mean?
Well, it's a vortex. So
well, I don't know. I've never, honestly, I've never done any measurements like that. I've never considered that. When I turn my coil on, say at 261 hertz and I'm holding a neodymium magnet, I can feel the vibration of that pulse.
Yeah.
If I put it at 7.813, that magnet will spin at 7.83 hertz.
Oh
yeah. It's pretty interesting.
Yeah, I would be definitely interested to know the maximum speed you could reach. Well, I mean, not like crazy speed, but just like a reasonable.
Well, it's weird. It's the magnetics disappears after a certain frequency, and it just starts giving you energy. And in fact, once you get to a certain point,
you convert from epsilon and U to K and G.
Yeah.
So I was wondering why with like the oh my goodness, Matt, the rife coils.
I'm just gonna step.
No worries, Mike. We'll be here.
I'm just gonna step up for a quick smoke. Right back.
Cool. For sure, brother. That at certain frequency wave, the magnet would stop spinning in the center or stop moving around. And you're saying that instead it's going into straight energy
production, yeah. And when you get into the even higher frequencies, it does other things. I'm just gonna say.
Is that why we saw some interference with the camera when it was?
Yeah, that's part of it. I can't. That's another thing. I can't turn it down. Sorry.
I was just complimenting Phil on his observation of noticing the A formations in the camera.
I didn't think anyone would pick up on that. Good job.
Oh, no, I did. I just didn't say anything. That happens all the time when I have different monoatomics around sometimes too plugged in. It's crazy just how much it actually affects with these like plasma EM fields it creates, I guess.
Well,
you have an electric field and a magnetic field. Of course, it's going to create radiation, you know?
Well, I wanted to show you guys a lower frequency, but I can't because it shows up in the speakers of my stereo and computer. And that's from like 10 feet away. So I keep it at a certain frequency. That way it doesn't affect things.
But I mean, if you could put like a gravimeter or
I use an EMF meter. I pick up the magnetic field and the electric field and the radio frequency field. I get all three. It just depends on at what frequency I'm pulsing.
And what is that again? Sorry.
It's a tri-field meter. That's what I use.
But the frequency, what is it you get?
The one I'm using right now is 261. That experiment was 261 hertz.
Could I ask you to show your tri-field meter? People are getting pretty curious.
Sure. Let me just.
And let me ask you another question while you're going ahead and finding that. If somebody were to provide you equipment or resources to pursue your work,
yep,
would you accept them?
I would. I would have to discuss with that person what sort of expectations they had and what expectations I had, so to speak. But yeah. Okay, so let's see if I can show you the tricord tri-field meter here. Oh, I gotta switch my camera. Hang on here. Okay. So that's what I use to show the magnetic field and electric field.
Okay. Nice. Because
it's pretty standard, right? Everybody's got one, or at least they should.
Yeah. Absolutely.
At least a version of it.
Yeah, some versions. There's many versions of it. I like that one. Apparently a lot of people use it. So
the analog is really a good solution. I've got only the electronic ones, and that's because I can modify them quite easily. But really, I prefer, I think, the analog in terms of what I would like to see from others.
Awesome. I'd love to get an analog.
Sorry, I missed the part. Do you use AC or pulse current?
I use pulse DC square wave.
Okay, pulse D. Okay. Yeah. Interesting. But yeah, that's.
I can't use AC. I can use sawtooth. I don't get as much out, and it changes the aspects of some of the things that it does, like the magnetic field, the variance in frequency from when the magnetic field shows up in comparison to when it disappears is different in a sawtooth than it is in a square.
Okay.
So yeah, it's a different system.
Yeah, I would be interested to do some calculations on your stuff for as long as you want to share the measurements.
Yeah, I could share as I'm definitely into discussing with you. Not on live, but definitely into discussing with you.
Awesome. Yeah, let's connect.
Absolutely. I think I have your email. I'm not sure.
Yeah, I'll put
If
it.
not, there's the private chat. So just you
Yeah,
guys can
yeah,
communicate
throw it
with
in the
each other
private
there
chat.
and exchange.
So I'm setting up an experiment in the very near future. I showed Jeremiah part of what I'm using, but
And I was impressed.
I'm going to be putting the coil under vacuum and showing this all over again.
That's pretty cool what you did. The vortex, well. Because there's a lot of potential, a lot of things. Just a magnetic field I calculated. Just a magnetic field itself has a frequency according to my. So frequency times the mass charge equivalence. But you have a frequency in the magnetic field, and you use to generate electromagnetic energy or gravity or whatever. Time. I know you said you don't like the idea that time is a chronon or a particle, but there's a lot of potential.
Well, that was just
Well,
me.
maybe
I don't know if he said
in
that.
a
I
third
said that.
dimension it does.
Yeah, I said that. I
exist
don't
in
like the
that as well,
chronon. I think that time particles are sort of ludicrous, but that does not speak for everybody here. That was just me.
Yeah, I think time is it's something that needs to be looked at, definitely. Whether it's a particle, whether it's a wave, whether it's both, whether it's a form of measurement only, it definitely needs to be looked at. Definitely.
Yeah, awesome. That's really cool what you did.
Thank you. It's taken a few years. Don't kid yourself. This isn't something that just fell into my lap, but yeah, I've gotten lots of shocks and burns and some skin damage to prove it too.
Sound like Mike right next to you there. By both of you, stay alive. Don't put out too much power.
My biggest warning when you're not using a capacitor, discharge it, please, before you do anything, because I learned that the hard way with a 15 kVA capacitor, and basically went right through my chest and knocked me off the chair.
Wow, that's funny you say that though, because now I've got like a ground pumping situation going on, right? And I have what is it? It's a 1,000 UF 250 volt capacitor, and I have it hooked up to the coil, but nothing's on. And I walked away from it, and then this morning when I came back to do a different experiment, I got a zap of my life, and I realized after I walked away from the table that it's filling up slowly on its own with nothing on, just hooked up to ground and the way the system works.
I have to mention this. The energy from the vacuum series, you guys that have the private link, please go ahead and pursue that. You're going to find there's a video in there, and I'm going to give you the title of it too. So let me just scroll up. I believe it's point 11. Okay, so this would be Moray, Sweet, and Anti-Gravity, parentheses 2009x264, Tom Beard and John Bedini. Watch that. What you just talked about, every one of those points is covered in that. And it's available from the same link that I sent you guys in the private chat. So please do check that out on Archive. The reason why I didn't want to share this link is because I think if it gets a little bit too popular, it's going to be ripped down like many things from archive.org, but should be pretty much invulnerable from things being removed, but that's not the way it works. So check that out, save it, download it, and then if you want to share it after you've downloaded it and have a local copy, you can go right ahead.
Yeah, I've downloaded almost all of them so far because they're amazing. Energy from the Vacuum series is just absolutely fantastic.
There's a really good one on the Lockridge device. That's another one I really enjoyed.
Yeah, that one was good actually. Bendini talked a lot about it.
Yeah, he had
Bendini.
a
I always say his
replication
name
of
wrong.
it.
Hard to beat the Conway generator, though. I mean, that thing is just mind blowing.
Oh, the Cromery. Yeah, I watched that one today. Yeah, that one's cool too. And the key to that one, the Cromery generator, the center axis or the axle used to spin that rotor has
Cannot
to be
ferromagnetic.
non-conductive.
That's not the real key
Right.
in that system. It actually has to do with the making and breaking and purity of the iron. Now Bedini does not talk about this in the Conway generator series from Energy from the Vacuum because he did not test ultra purified materials, which would have been egregiously expensive. But if you go beyond 99.6% iron to 99.8 to 99.9% iron, your effect, it increases asymptotically, and you get a tremendously larger impulse that comes shooting out of that system. Much higher voltage, even lower amperage, impulse speed even shorter. You get the coherent states of matter with the higher iron percentage.
Know where you get that material from? And actually, this came from Paul Babcock. Number 7 birdshot that you use to put in the bullets. It's number 7.
Unfortunately,
Yeah,
not
I've
anymore
heard that.
because of the recycling. It used to be like that in the 90s. It's not anymore. Just a fair warning.
Well, I got a few boxes of shot
what
from
you're
the
after.
90s.
Yeah, so use that material as your core material because it's very low carbon. They call it like soft steel. I work with metals all day long, and that's what you need to work with. So after the magnetic field gets shut off, the iron loses its magnetism right away. If it has carbon in it, it will delay that collapse. You want that field to collapse as fast as possible.
If you wanted to know where it comes from, I can tell you how to look for it. So in your case, Mike, I can tell you how to look for it, and it's actually ultra simple. Wrap yourself a very low number of turns coil around your high purity iron material. So you're going to have, say, a rod or a stick or, say, laminations. Don't use any other low carbon, or excuse me, don't use any other high carbon materials. This literally will be prevented from happening because the carbon rectifies it. It actually has the opposite electron spin, so it destroys the phenomena. Wrap, say, 10 to 20 turns around your iron. Simply bring a magnet close to it. Look for the Bachhausen noise and compare the Bachhausen amplitude input to the oscilloscope at your low number of turns to what you would normally expect from Bachhausen noise in a high number of turns or high impedance pickup coil. What you'll see is that the extremely high purity 99.8 or above % iron produces an amplitude over 2 to 3 orders of magnitude greater. The velocity of that amplitude going through the same material is also equally higher, and so is the total duration. Hence, the energy density for the event becomes shorter and shorter until it actually becomes large enough to affect mu in the localized space-time refractive index. And now you have access to a warp type effect. And this is what they were all utilizing. It used to be that we had high purity iron. It was a natural part of the industry. Now, everything has been augmented with rust preventative agents, and it destroyed the phenomena.
Yeah, that's if you can get your hands on that low carbon iron, that's your best material to work with by far. And anyways, to make a long story short, Paul Babcock started making this core material with this number 7 birdshot, and he said it was like night and day. It was a complete different effect.
Just make sure you get old birdshot from the 90s or before. Technically,
I'm wondering if
1984, but I've heard that some of them still had old stock that you could buy, but don't expect new stock today to have that high purity. It won't.
I got 2 boxes of that old stock, so I might crack a few open and see what I could do with it.
Yeah. So all you have to do with that material is put it like on a cardboard sheet and get some spray silicone and spray the beads or the pellets with it. and shake it around, spray them again. Try to put a coating of silicone around each and every one of those pellets, and then put it into whatever form you want to put it in. And then
use
bond
that
it with
as a core.
silicone or whatever bonding material. Yep,
That's awesome.
exactly. Try it out.
I'm actually writing down the experiment right now.
That is real science.
Yeah. Most
Experimenting.
scientists have a memory. I believe that.
Phil, did you want to discuss some of your recent work with the time dilation and stuff? Or?
Sure. I made some preliminary experiment this week. I've got YouTube videos I can show. I'm just gonna share my screen. Okay, so it's this one here. Okay, so this is my channel right here. Can you see that?
Yes, sir. Thank you.
All right. So I did some experimentation. I'm confirming it. These are all preliminary. What I'm doing is I put a clock, a digital clock on a 1.4 Tesla magnet, and exactly in a similar clock away from the magnet. And the clock actually on top of the magnet, actually, they're not perfectly synchronized, but the clock on top of the magnet is actually going to speed up. So I'm going to show you the first video. It's the clock again. The clock on top of the magnet is a little bit behind. I did that experiment like 3 days ago. I'm going to show you what happens. Okay, so now we see the clock on top of the magnet is a little bit late, like 1.6 seconds too late. And 72 hours after, we see this.
Wow. So magnetism is essentially slowing down time a little bit.
No, it's actually speeding up.
Speeding it up.
Sorry.
Yeah, it's speeding up, and obviously this is preliminary. I need to use I'm repeating the experiment with different clock, and I need to repeat it again with anti-magnetic stopwatch, because there can be like a magnetic interference with the chips and whatever. But this is very preliminary, but so far so good, because this is a prediction of finite theory. Because finite theory, if you look at the measurement unit of a Tesla, it's a kilogram per coulomb times hertz. So it's a mass charge equivalence times a time rate. And the time rate is what actually affects the time field. So once I fully I fully complete a full scientific experiment, then that's gonna be foolproof. It's gonna be pretty much scientific evidence that general relativity doesn't work, and all that, and that my theory works. So so that's where I'm at right now, and if anybody can definitely repeat it if they want, they're gonna get. Actually, I get 1.1 second time shift per day per 24 hours for a 1.4 Tesla magnet. There are two 1.4 Tesla magnets. But you know, I'm not sure if Tesla adds to. You can add the frequent through the. I'm not sure if you can say that the total is 2.8 Tesla.
Well, Phil, there's a bit of a conundrum here because on my end, I've got a way, way larger drift than that. The only problem with it is it has no measurable magnetic flux. It happens to be only the measurement of the electromagnetic acceleration of charged particles coming from a very thin, negatively charged corona wire under standard atmospheric temperature and pressure, positioned just slightly above the table of the laser interferometer. Now, we've got 25 fringes of displacement consistently, but the odd part is if we run that system and it takes approximately 60 seconds to get our 25 fringes, I've never allowed it to run continuously to see just how far it might go. I've stopped it at 60 seconds every time, being quite uncertain about what the results would be in terms of their impact on my table and possibly the local time space. But here's the weird part. It seems to be connected to the localized environment, meaning if you move the laser table, the fringe pattern starts to shift.
Oh, yeah?
So it's almost as if it had conditioned in the variable refractive index are localized space-time metrics. Now, it could be K or G or E or mu. I'm not going to say that I have the ability to measure it, but I will say that it seems rather simple. So just consider taking a lifter, nothing more complicated than a Jean-Louis Naudin lifter from JLN.com or any of the other many lifter applications from around the world. Place a laser beam through a very tightly packed multi-emitter wire lifter, say no more than 8 millimeters apart from each other and no more than 10 millimeters from their collector plates. Place a series of those in a row. Place the laser beam, then pass it through the space between them and keep it close to the collector plates where the electrons have gained their highest velocity. At that point, measure the laser time velocity differential and its drift from what it should be. You'll see it on the interference window of a simple single-pass SPL laser interferometer. My table is made of non-conductive materials. I specifically chose that so that RF interference would not give me other consuming or erroneous effects. But you could use a metal table.
Yeah. Yeah, that's interesting.
It just seems like there's a lot more powerful effects here than a low-speed rotating magnetic fluid.
I need goggles, proper goggles for my laser for doing any interferometry tests, because I got this really cool laser, but I don't have goggles to protect myself from it. So, because it's like a 2.5 watt. It says it's a 5 watt. I doubt it's a 5 watt laser. Probably more like a 2.5 watt laser.
Regardless, you've only got one set of eyes.
You don't want to go blind. Yeah.
I almost burned my own eyes out just testing it the very first time like a dummy. I got the reflection flash. So that was enough to hurt. And I don't want to ever turn them on again until I have the right goggles. So when I do get them, I'd love to try that test.
Yeah.
Oh, I should answer this question too from the chat. Speed recovery. How long does it take for the laser interferometer to actually recover? Well, the 25 fringes that take place do not instantly turn on and divert 25. They take, like I said, approximately 60 seconds to reach that point. I shut it off. I physically remove the device from the laser table that was causing the interference shift. The power supply is then at that point off, and the interference table is sitting in the same environment within the same position to surrounding matter, except for only one thing. The device that produced it, which was very lightweight, was removed, and the power supply has not moved position, but it was turned off. It takes just about as long to come back to rest as it did to shift, which leaves us with a very serious question to consider. Is matter actually a catalyst for this phenomena, or is this locally in just the space-time alone? It's a very important question to answer.
Interesting question. It's going to take a few people to do the same experiment to answer.
Yeah, but if technically you can control time through magnetic field, then you understand that the potential it has. You can create superluminal communication, force fields, and so on. So yeah, there's a lot of potential, man. It's a pot of gold right there.
Yeah, force fields are they're interesting.
Yeah, because you stop time, so
That's
any
why we've got the
potential-
3M force field generator sitting on the shelf over there.
Yeah.
And we'll be building that very soon, too. We're going to find out whether the claims of Mr. Swanstrom and Andy McCurry actually went there 1 week after Mr. S and had experienced the same effect.
Yeah, definitely.
Multiple witnesses is usually a good sign.
Yeah, from different angles with different theories, and we get the same conclusion. That's pretty awesome, I think.
Absolutely.
Combination of forces and you all verify each other and create a stronger, verification process of advancement.
A giant pyramid of giants whose shoulders we all stand upon. But nobody said it better than Gerald. I wish he would give his quote because he's got
I stand on the shoulders of a million men. Without them, I'd be no one. Right? That's just kind of how it is. And there's a very other part that's very important to me that if it wasn't involved, I wouldn't be here either. But we'll get into that in another future video.
Yeah.
Yeah, my life's crazy. Let's just say that. If I counted how many times that I came close to death and told you half the stories, you'd ask me why I'm still sane.
Well, at least you did actually get the chance to go all the way.
To death? Yeah. Yeah, when I was 15 and a half, I died. I'll tell you, there's life after death. I don't care what anyone says. There isn't a person on this planet, not one, that can change my mind from that. I've been there. There is life after death.
Same here.
Only your own.
I'm still alive, maybe from my car accident because it was pretty bad. Sometimes I wonder if there was a force field that protected me.
Or a hand. You never know.
Right? That hand so many times shouldn't still be here, but you have your purpose, and that is why, because you're supposed to be until
Mike's
it's done.
here, Phil's here, Gerald's here. I mean, you guys, you must have some kind of greater scope in this whole entire human experience, and I don't think any one of us could dare say that we could comprehend the complexity, the intricacy, and the significance of what it actually really is to be a human being on planet Earth. But I'm sure glad that we get to be part of it.
Yeah,
you know when my car accident actually, my car accident helped me figure out not to waste my time with things that does not matter. So now I'm wasting time. I'm spending my time in things that matter with you guys. That's.
I agree.
Yeah.
I hear that.
Yeah.
Mike, you keep trying to say something. I think your mic is not.
Can we all shut up to give Mike a chance because his mic?
Yeah, I'm sorry, Mike. Yeah, it seems like you have a delay sometimes.
Yeah, okay.
Go ahead. I'll shut up.
Yeah, it could be because I'm linked to BurnEye's stream. Maybe that channel's lagging a bit. But yeah, what I was going to say is, all of us have been into this stuff for quite some time, some of us over 20 years. We begin to wonder what the whole nature of reality is, because the stuff we're working with and what we're taught in school don't converse. There's something totally off, and obviously it starts affecting you deep to the point where you start questioning your believing in God and stuff like that. How did this whole reality start? Well, what started it? There had to have been some kind of divine intervention or control that started this whole realm, that leads us to such a, I guess, a very diverse universe, and the way things evolved, and the formation of complex organisms, and then it led to life on Earth. So when you start working with this stuff for so long, you start thinking to yourself, where did this all begin? Like, where did it all start? Right? And that's probably one of the biggest mysteries that us as human beings are going to face, is what started it all. So some people go back to a belief system, God, right? And God is kind of like the demon word in academia. They do not want to cross that path. But when you start working with this stuff,
right? Like, absolutely. Like, there's conscious creation and intelligence and like design within like the physical realm and like the universe, right? That like the more you see it, the more you see the code. Yeah, it's kind of undeniable. And then by having that removed, spirituality removed, you also have consciousness removed, and then there's a whole missing area of interconnected science, essentially.
Okay, so I wasn't going to bring it up, but since you did now, I have to. When I died when I was 15, and I say that there's life after death, I'll say this: God is real. I don't have faith. I know. And I say that beyond the shadow of a doubt. God is absolutely real. And I know academia, like you said, hates hearing that. A lot of people hate hearing that. Why? Because maybe they feel they have to answer for their sins. I don't know. That's between them and him. I have no idea. But I'll tell you this:
boils down
he was the one that led me to this system. He was the one that led me to build this coil.
That's right.
So take it for what you will. Take it with a whole truckload of salt. I can only tell you what I lived. Go ahead.
Yeah. Sometimes people can't accept the truth. That's the problem. Like, all of us can probably have our own personal experiences when it comes to this, but
a lot
it's
of
kind of lost for words because it's such.
Yeah, no, you're not wrong. And a lot of people. I'm sorry, Mike. There's a delay.
Yeah, you're doing lip sync.
Yeah, it's there had to have been some divine control in the beginning of everything.
If I don't mind asking, could you mute yourself, Phil? I'm getting background noise from your end on my side. I think that may be what other people are hearing. Thank you. Okay, please proceed. You and Gerald.
Yeah,
everyone else is muted, so me too, as of now.
No, it boils down to everything had to have started from somewhere, and it had to have had a divine control, period. This is not a freak accident. We're not a freak of nature. This was all by design, and there had to have been God that was able to have that divine control to start everything.
Absolutely.
So, we're not a freak accident, is basically what I'm trying to get at.
Well,
can I ask you a question, Mike? Sorry, go ahead, Gerald. You first.
I was just going to say, for instance, in the science, like the Philosopher's Stone, alchemy, for instance, everybody's looking for the way of turning gold to white powder, or is it that they wanted to turn lead into gold? But if you look back all the way into the Bible, like back into its like conception, the very first story of Moses, what he was talking about was turning gold into a white powder. and then he would feed it to the Israelites. Why? Because that was manna. And in the Egyptians, they called it mifkit. And alchemy called it the philosopher's stone. And what was it for? It was super highly energetic atoms that were meant to get into your body so that your body can assimilate that energy without having to eat a ton of food in order to get that growth. That's what it was for. That's science right from the beginning. And where does that science come from? Well, if Moses went to the top of the mountain and spoke to God, and God was speaking to him through plasma, and he believed in him, and then all the science that we have today that I believe will eventually point back to him. It's just very interesting. Go ahead.
It did for me.
It did for me too, actually. My life was totally on a different path. 100%
I
on a
was an
different path.
atheist, full out, flat out.
Myself as well, yeah, right? And through alchemy, you find creationism and just intelligent design everywhere.
You know, with me, it's the biggest mistake I did. You know, when you're young, you think you're invincible. You know, when you're 20, you think you're invincible, nothing's gonna stop you and things like that. That was the biggest mistake I made. And then I had my car accident, and then I realized, wow, you know, we're just a grain of salt in the whole universe. We're nothing, you know, compared to God and other forces.
Twinkling of an eye.
Yeah.
Yeah, we're literally dust in the wind, and that song is so true.
Yeah.
Nothing as simple as this little cube magnet should allow somebody to completely reconcile an amazing experience and learn something brand new about the universe simply because you happen to have a bunch of magnets stuck to a rotor and you bring this close. But that's what did it for me. And G told me about rotating magnetic fields, and it wasn't just him. It came from many, many mentors. I had 7 great mentors in the year of, well, 2013 now. From 2012 late to 2013 now. And from 2022 to 2023 now, I had many great mentors in the most recent iterations, 7. And this magnet did more for me in terms of physical experience simply by placing it close to a rotating magnetic field. There's nothing realistic to say about trying to support this as a claim, but it cost me $13 on Amazon. So I suppose if you've got $13 and you can stick something on a rotating disc, a couple of magnets, and bring it past, you just might happen to experience something very strange.
Yeah, rotating magnetic field is very significant. It's more important than most people understand. Well, if you think about it, that's how our planet moves and rotates, correct?
We certainly do have a rotating magnetic field, and without it, we would have no atmosphere, and we would be destroyed completely by the solar energy particles that come constantly flowing in at, according to Richard Feynman, 700 million volts at 400,000 amps.
But think about it, a magnetic field and an electric field, it has an equivalent mass. If you can make that spin very fast, it's going to generate gravitomagnetism, which is anti-gravity. So that's why I was asking these questions earlier on. Yeah, what you're doing has a great potential right there.
Yeah, and the higher the voltage that goes into it, the stranger the effects become. Let's just say that.
Yeah.
But let's not have to generate those ourselves. If I may, Gerald, you already figured it out, and you got access to the Earth currents, and so did Adam Micon, as goes by Space Case Zero, in tapping the Birkeland currents. I don't know if Mindful Exposures or BurnEye, if you could link to Adam Micon's channel, Space Case Zero. All one crammed together word. But he's got live experiments there.
All these different areas are actually converging.
Say that again,
all these
Mike.
Different things are all converging together. It's like all these things that we're talking about, they all converge together as one. Anti-gravity, over unity, magnetic fields. All this stuff is all interconnected with each other.
Exotic vacuum objects.
All the different areas.
All of the works from our greats before. Bedini and Bearden, Dollard, Moray, Hutchinson, Tesla. I mean, we could keep on going back to Faraday.
Faraday research.
Incredible to reference for you, and of course, Maxwell. Even Heaviside had his contribution. Without him, if he didn't simplify the equations, we wouldn't have an electrical power grid, first off in the United States, and eventually copied and replicated elsewhere throughout the world. So somebody had to simplify it, and that was also important. It just is unfortunate that modern-day academia tried to make that their standard.
Well, there's a reason for everything, and everything has its reason.
Yeah, don't forget Steinmetz.
Yeah,
Don't forget Steinmetz. Yes. He was a big part too.
Let's not forget Steinmetz. Anyway,
and
please, nobody bring up Ken Wheeler.
Oh yeah, he's really good. He
no, he's not. Sorry, nobody bothered to give that guy a copy credit because it's just plagiarism.
But he, well, I don't know. I don't watch all his episodes, but he actually noticed a gyroscope next to a neodymium magnet. Doesn't have a constant speed depending on the position next to the magnet, and he also noticed the light bending by a magnet. Another experiment. I mean, I'm not saying he's perfect, but I don't watch all his episodes. Sometimes it's too much talk. But I saw these experiments at some point.
So, I like the simple idea of his experiment. The only one that I would recommend is take a tube TV, put static on the screen, drop a magnet past it, and measure the amount of time it takes to fall, and check that when it's not turned on. That was about the only good quality experiment that he's done. Everything else he copied from Omega ZZ, from Eric Dollard, or from others. So you might as well go directly to the source and not on his channel. I also want to recognize Mike Dos mentioned Max Planck. Absolutely critical. Max Planck is the one that recognizes the positron-electron pairs in the vacuum and talks about the energy density criticality of these interactions. Of course, then we have Lorentz and the Lorentz transform. And let's not forget when Einstein worked with Descartes. So he tried to create this unified theory, and that's also extremely important. Many, many names. In fact, so many we can't realistically remember all of them. But I did want to mention this one, Santilli.
Oh yeah, Santilli.
Girlfriend brought Santilli to my attention, and his disclosures are so good. Holy shit.
Ruggero Santilli?
Yeah, Ruggero Santilli. You know him.
Oh, I know him. Yeah. I've been to his conference in San Marino in 2011. A long time ago.
To clarify Santilli in one simple statement, he recognizes that there is no such thing as a mass energy momentum tensor. We are told in all of physics that gravitation comes from mass, but there is no mass tensor because mass on its own has no energy momentum. It's a static, continuous, stationary value. Therefore, there is no energy compared to the vacuum. What he says is, instead, let's take a look at how this actually applies to the Newtonian physics and integrate them into what we already know from general relativity, that we have something called a stress energy momentum tensor, or simply an energy momentum tensor, which means there's extra energy in one spot of space compared to another spot of space. That's all it means. It's not more complicated than that. Gravitation comes from a low energy place in space and the matter that is contained within it trying to move towards a higher energy state in space and the matter that is contained within it. It also works for energy density, meaning electromagnetic wave interference, as Tom Bearden talks about. These concepts, they're not all too complicated, and in the end of the day, you add energy and momentum in the form of radio waves or accelerated charged particles or high velocity for randomized motion of particles, and you end up getting an amplified force of gravity, what we would call a gravito-electromagnetic field, meaning it's an all-encompassing term talking about how much stronger electromagnetism is than gravity and how it has a gravitational equivalent because the fields are too fast for the electric component or the magnetic component to actually take place in a measurable sense. Phil is trying to do exactly this with his rotating gallium device. And right now, his biggest challenge is to increase the velocity of that rotating fluid in its ionized state in order to achieve a very, very high energy density. But of course, it's not the only way. And that's what we're here to do, is figure this out as a team, as a group together.
Yeah, and so there are two ways to. Like I was saying last time, the people think gravito-electromagnetism is weak, but it's true that the permeability of a gem is weak, but there's also a relative permeability that spikes it up. So that's why we don't need astronomical numbers to create anti-gravity and things like that. So I'm repeating myself. I said that the last time, but I just want to, people to remember because it's very important.
The experiment that I showed you earlier with 261 hertz, basically 0 watts input, that magnetic field is crazy strong. If you're holding a magnet in your hand, it almost feels like it's ripping it out.
Oh, yeah.
So, yeah, I don't think we need the amount of power that's stated.
Yeah, you need seed power. This is what I've been telling everybody for a long time. The power is created within the coil. As long as you provide
you say
the right
seed
voltage,
power, Mike? I'm sorry to disrupt you, but I want you to say it again because what you just said was so important. Can you say that again? The beginning term, seed power?
Seed power. Basically, seed power is something that starts the reaction. The real magic happens in the coil, the inductor, with the frequency which you modulate the seed power into the inductor. The real magic is happening in the magnetic core and the coil. It depends on your configuration, but the real power is generated within the coil itself. The voltage going into the system is just to start this reaction.
Yeah, I agree.
So if you put the proper voltage with the proper frequency. Go ahead.
Sorry, Mike. I agree. If, like, according to Thomas Bearden, what you do is you create the dipole, and then you would feed that dipole like minute amounts of energy, but just enough that it takes to keep the dipole going, and then you could tap the dipole on the other side through ferrite. And by doing so, as long as you keep that dipole going, you're able to basically tap the vacuum, if that's the way you want to look at it, or tap the electromagnetic flow of the energy itself.
Exactly. If you're right. So if you tap the electromagnetic energy that's created from the inductor, you're not going to kill the dipole. That's one thing that Bearden says. Do not kill the dipole. Leave it alone. You have to pull and extract the power coming off the field itself. If you directly tap off it, like physical wires off that dipole, you're going to kill it. Right there, it's dead. You got to leave the dipole alone. That is like, it's kind of like the dynamo of the system. Leave it alone. Feed off the flux or the fields being generated by the dipole.
Yeah, we don't put so much energy into a motor that it completely catches fire and blows out. Well, unless you're me. But what we need to do is recess that dipole, or we need to vibrate that dipole, or we need to oscillate that dipole. But in any case, we're not destroying that dipole. We're not actually neutralizing an imbalance in charge between two physically separated points in space-time which are self-stabilized. We're simply oscillating them so that we get a response from the cosmic background that has been called virtual particle flux. I propose, personally, that virtual particle flux is a misnomer and that we have real physical electron-positron pairs that temporarily separate and recombine, causing a distortion or a displacement in the physical volumetric space. And this allows us to do impulse beams, gravity impulse beams, extra energy output, or a variety of other phenomena. But just to keep it simple, we don't destroy what we create. We oscillate it back and forth, we precess it, or we vibrate it. With those three options, we can extract the energy in comparison to the surrounding background because it's a warp drive effect. It's not an electrical current flow. It's a change in the index. And it costs us nothing except for the initial energy to have a high Q system and oscillate it. So the higher Q, the better we do.
Well, all three things do different. They give you different aspects. Like if you were to pulse it or vibrate it, or it all gives you a different aspect of the system itself.
Yeah, your over 100 coils certainly showed plenty of different phenomena.
I've got 18 tutorials thus far. I'm getting there.
Could we try to push you towards uploading on Rumble?
Yes, please.
Yeah, actually, I'm trying to get a Rumble account. I thought I had one, but I got signed out, so I don't know. I'm gonna play with that and see if I can get uploaded there. And I got a new computer coming. I'm gonna see if I can get onto OdySee and Twitch and every other format that I can get my hands on, and release them all.
First thing to do when you get your computer, install Linux and wipe out Windows.
I agree.
Yeah.
Right? Oh, God, it's the worst. Windows is the worst. And there's got James. James with us. James, my friend. He's upstairs. James does music. And James is still muted, I think.
Hello, James.
Oh, I'm going to have to go unmute him.
Somehow, turns out Falcon is still awake. You wanted to send him a link, yeah?
Yeah, I've seen him in the chat. That's Mark.
That it is. We're going to see how well we can get along in Jersey.
You going to Jersey? It's a cool place.
Yeah, good old Jersey. We'll see how
I
it
actually
goes.
have a friend in Jersey right now. I should get her to. Yeah.
Well, he did do the incredible job of coordinating this effort. I brought an idea to his mind, and what did his mind do? Well, it put it all together and said, this is what we need. I'm going to go ahead and take care of it exactly right now, and then we'll see you in a couple weeks.
Awesome.
And so here we are. That is credit to him for doing what I could not do.
Are we going to see you in the lab soon, Jeremiah? Is that the idea?
I would say it's pretty well inevitable that you'll be getting a live stream from me coming from there.
Farganay, brother. You got to wear the lab coat, though. You really got to wear the lab coat.
I'll be shipping my own. We actually already talked about that, ironically.
Right on. I got to get myself one of those. I haven't got one yet.
Oh.
But I'm going to have to dip out, guys.
Yeah, it seems about that time. There
All
are
right.
I've got to do as well. So
I got a few things to do, and then I gotta get up early. You know how it is. So
fair enough. Well, I guess we'll just do this again next week and have Mark on as well, Falcon Space, and for next Saturday, I'm going to aim to do the Science of Sound, where we will have James back on, as well as Ominous beatboxing again, and get into mixing the science into music and trying to make that music that heals.
You bring Ominous back on next weekend. I'll pull out my harmonica set.
Well, you can pull it out right now, and James will freestyle over some harmonica for sure.
I think
Yeah,
I better
I'd be
practice
cool with
a little
that.
bit.
Oh, let's push him. Come on, buddy. Do it.
What?
And James has an album being released right now, right? Or midnight, 3 hours from now it goes live.
Midnight Eastern time. So whatever. I think that's
So 1 hour from now.
Oh, that's cool.
Yeah. Yeah. No, it's dope. Gnostic, all platforms. GNOSTIK on all platforms. The album's Hypnosis Volume 2, and it's kind of a follow-up album to Hypnosis. It's just Hypnosis, but this one's Volume 2. So it's going to be like a 3-part series that I'm doing. And yeah, that's a really good album.
Oh,
So
sorry, Hypnosis. Can you, is this like a subliminal messages type of thing?
There's elements of it that's like healing, I think, like because I do like chant, like some forms of like chanting in some songs, you know.
Okay.
And I don't know, subliminal messaging, like I literally do have a part in one of my songs that's like talking about subliminal messaging, and I do it and I repeat it 3 times and shit, and I do some magic shit like that and some but I mean, like, yeah, it's an experience, man. Like,
Yeah, as long as it heals, you know.
yeah, and for me, like it's healing. It's like a journal, you know. It's like having a journal to be able to, like, you know, share with the world. And then, you know, I think that's the coolest thing as any kind of artist, whether you have anything that you can give to somebody and have them enjoy it, you know.
Yeah,
And
you
have
put your heart
them get
out there.
have them get something out of it. If they're like, you know what, man, like when you said this one thing, like it made me understand this thing about me or my life. Like that's the gem of music, right? And I think that's what I like about it a lot. So
Yeah,
That's art.
As a fellow DJ and music producer, I can certainly agree with exactly what you're saying there. I've used music on many occasions to even assist in the process of reaching breakthroughs, scientifically wise.
I think music can change. Music can, and I believe it still will change the world. It has that ability to cross barriers of perception with feeling.
Right? Music with soul. The music
Yeah.
with soul resonates.
You can't. You can't. It doesn't matter. It doesn't matter what you think about something. If you feel something, it could change your perspective on something altogether. And I think that music is one of those only mediums, no matter what language you are. And I think that's why, in a lot of cases, I think in some ways, I think English people in general, because of our white magic past, I think we've mastered that, and I think that's what makes us such good singers.
And going beyond that to the super esoteric woo-woo, I just got to mention it before G has to go here. He's found that very specific frequencies, because they're so controlled and because the rise time is such an insanely fast, ludicrous speed, certain frequencies have really profound effects on human psychology.
Yeah, it makes you smarter. Sometimes
I hope he can comment on before he goes. So let's just give him the floor.
Yeah, absolutely. In fact, if you're playing with the wrong frequency, you could cause issues amongst people that are around you. While I was doing experiments, I inadvertently, accidentally, I'll say that, disclaimer, caused arguments between everybody in my house. They all started bickering at little, just small things. And it kept getting louder and louder to the point where they're almost at the fists. So I shut my coil system off, and then I recalibrated it, went back to 7.83 hertz, turned it back on, and everybody started to calm down. Now, I don't know if it was because of the electromagnetic field that was around.
No, because you're just saying that. And like while this stream was on live, I pulled out the Z app thing from Matt Rife and started like messing around with his coils again, putting a couple frequencies through it. And I haven't done that since the first time I did it, because like I would get like all tense and like start getting angry from like having it on, because there's none of like the Solfeggios or the 432.
That's the wrong
like,
geometry.
off ones, right?
If you nerdy guys are after like
once
sci-fi,
again I started getting like tense and like starting
But
like
that's
annoyed and agitated.
So
But
Star Trek TNG episode 91, called Night Terrors, covered specifically this phenomena as a result of electromagnetic interference that was too extreme. This was way long ago, long before Havana syndrome or those types of things, which Mr. Sokol, who is now on, has personally had the opportunity to unfortunately experience.
Really? That I'd love to hear about.
With that ex-girlfriend, right? That was that one that was like that you're targeted, right? Yeah, Jeremy speaks of it often.
Yeah, the time traveling anti-gravity princess.
Nice.
But it was a fake call on uranium that gets you visited. Yeah.
That's why
What was it?
that's just dangerous. They do that stuff at like for riots if they want riot. Like
LRAD. Yeah, LRAD.
Like at concerts or whatever. But they do that through music in general. Like that's why like there's such low vibrational music that gets pumped, you know, and like because there are certain frequencies, and that's why I say like my album's a journey of that. It goes through the highs and the lows through that, and I think that's why I think humans are better equipped with being able to. If humans are the producers of the psychological warfare, it's a lot safer than those like just blank like just emittances because that's uncontrollable, you know, and it creates such a wave, and like you can control it, like DJs control it at clubs through music that they play and everything like that. Like everything's on a frequency, right? So like
yeah, I can tell you from being on stage in front of almost 10,000 people, you feel it.
Oh, dude, I've had thoughts of like, you know what, like I wouldn't doubt it if one day you could have levitation from frequency on stage. Like
I've been so close to being in front of a huge number of people that and playing these tracks. I actually had a little roster labeled levitation, and I never played it. I should have done it at least once when I was on stage at the Eagles Club, because it's the biggest venue in Milwaukee, Wisconsin, and in the state of Wisconsin. But I didn't. I wanted to ask the audience in some way through the music track that I had written, please focus on this. But, I couldn't bring the object in with me, and I didn't want it to be a person. I wanted it to be a thing. Maybe that was a bad choice, but we never did end up doing it.
I had visions of it once, of what it was, and its intention. Everybody has to intend on something, and what it was somebody was dead, and the intention was for levitation and to bring back to life, and it happened through through harmony and frequency and chanting and love and music and positive vibrations and shit like that.
How are you supposed to present that to an audience of a bunch of people who probably at least a third of them are on some substance or maybe completely disconnected from reality? I mean, how do you actually bring that out?
The only way that you can actually like do this through music and unite everybody is you get rid of alcohol. Period.
Well, there's no way that's going to happen in a bar.
You can't be on the same frequency with alcohol. Every alcohol is a different frequency. So you can't.
It's funny you bring that up though, because my aluminum freaking tetrahedron pyramid that I made, every single sober person that ever held it was like, "Oh my god, it's so hot!" It like would heat up and it would like burn your hand. And if you were drunk, you're like you couldn't feel anything, and you're like, "What the fuck is this stupid thing that you're trying to make me hold, Bernie?" Was like I tested 100 people. It was like 10 drunks, nothing.
No, that's
anyone else.
And with alcohol, it's spirits, right? So like it can be tapped in. So if there was any force that wanted to tap in from like the other side of like say there's somebody that just didn't want to and they were strong enough and had like an army to be able to do something on the contrary to that, they could fuck with people through drunk people.
No,
Just through the
Gnostic,
resonance.
are you
Can I
saying
pause this just for a moment because I can see
you're encouraging prohibition and alcohol?
I know, man. Well, that's what. Honestly, man. Honestly, and that's why like drinking, it should have only ever been ritualistic. Because and that's what like in biblical shit, it's ritual. It's like no, you only do it with in your safety of your like most loved ones at cherished moments and shit like that. But it's become a problem. You know what I mean?
You
Now
let the demon out through the alcohol. Is that what you're saying? You're letting
I
a
hate
spirit?
spirits. That's why they call it spirits. Like because they can enter into your and they can with cannabis too. And
Well,
so like different
James, I'm not going to disagree, but that's more for an alchemy stream, not for the real science. And Gerald, sorry,
I hate to interrupt. I gotta go, but James, I love the way your thought process is going. I can definitely have a long conversation with you about that, but I have to go. So you guys have a great night, and James, hopefully I'll get to talk to you soon.
If you don't have James' contact information, and if James does not have yours, I'd recommend that you guys use a private chat before either of you jump off.
James is at my house, so I'll email you. We're good, Gerald. Much love.
There you go. Perfect.
Okay,
We'll have James back.
Talk to you soon.
And my MC name is there's a K at the end of it now, Bernie. I don't know why, but the rebranding of Gnostic
with the
Later, guys.
K now. My rebranding. I don't know.
About alcohol, alcohol numbs your brain down, so I don't think it has the potential to bring in any new energy into your brain. It's killing your brain. It's slowing you down. It's starving you of oxygen. You can get other spirits in there, and by spirits meaning like wave patterns in your brain that make you think of different things. But those are more like the hallucinogenics and the weed and stuff like that can do that. I don't think alcohol can do. Alcohol does bring us back to our root, and our root is our animalistic body. So humans get into fights. They get violent when they're drunk.
Yeah.
But I don't think it brings in any other, energies. Not that it's good at all. No, it's not. But Jeremiah knows a lot more about alcohol than I do.
Yeah, I'm a big fan of the ethanol. I've brewed it all my life, and it runs in my family bloodline. It happens to be that we have a really ridiculously high tolerance. When Mark and I first met, and before we started APEC together, well, we both kind of devolved in it, but he's since quit that, and I think he's refined down to a lot cleaner substances that aren't ethanol. So I agree with what he's saying there. Ethanol sucks. It's actually a kind of crappy substance. And overall, it doesn't really seem to give us any major benefit in the long term, but it certainly helps reduce the stress in the short term. Unfortunately, it's just a fake. It's like a cheap patch.
Actually, can I pitch in something? I was after my car accident, I was completely amorphous. I had no feeling or anything, and doctor said not to drink alcohol. That's exactly I did the opposite. I moved to San Diego, started drinking like crazy, and then I kind of rejuvenated me. I kind of had life back into me, because when I read a paper about alcohol saying when you drink alcohol and then you stop, you're gonna have a neurogenesis in your brain. So I figured, well, I'm gonna drink, stop for a while, and then drink again, stop, and go on a cycle like that. It obviously did not make me dumber than I was. So I don't think I'm dumber than who I was 20 years ago. So that's
What is? Oh, that is temporarily over there at Mark. I'm going to just mute him for a second because that drill is rather loud. I think it was him.
Yeah, Mark is on mute right now.
He's always working.
Oh, I'm not always working, but actually today we're setting up LabVIEW over here to get in all of the data from the different experiments. and I decided it's finally time to do some wire management. So I'm doing some sexy wire management, just trying to tighten everything up and make room for it. It actually looks pretty nice. Let me give you guys a zoom in on it.
Free lab tour, Supercut from Falcon Space.
Yeah, so we got the wires like all organized, power supply hanging on the ceiling. That one's over there. Everything's pushed back as far as possible. And next, I got to clean up all this wire mess. That's it.
It's very nice. Looking good, Mark.
Well, you could show a little bit of the preview of some of the materials we'll be working with in just a little over a week.
It's on the other side. Sorry, I don't know fit over here, but those magnets scare me. They're very powerful.
The neodymium magnets.
Some of the best.
Shit, not the stuff you buy on Amazon. They're the real shit.
Yeah.
Yeah, the N52s you buy on Amazon are not N52s.
They're closer to N38s, to be honest. You may as well call them refrigerator magnets because that's about as good as they are.
No, not everything on Amazon is the same, but yeah, the stuff on K&J Magnetics is definitely really good. Really good shit there.
I've heard good things about Super Magnet Man, too. Just never got anything from there. But I believe they're focused more on custom magnet shapes.
They're not going to be custom magnets.
That may serve us very well later on down the line.
I bought mine from Magnets for less from Seattle, I think. It was like $200 for the one ring magnet. Two or three.
Right.
Yeah.
So
Do you have
much
a
real
good surprise for tomorrow, Mark?
Yeah, maybe I'll schlep them over here tomorrow. They're like a 1/4 inch thick by half an inch cubed, and they have like 25 pounds of lifting force. So that's over a 1/4 square inch, 25 pounds of pressure on a tiny little thing that's a 1/4 of an inch thick. So they're really like once they connect to something, it's very hard to remove them because they're smaller than your finger, and yet they have 25 pounds of lifting force.
Awesome. Yeah.
I actually sprained one of my fingers trying to remove it the other day.
Yeah, you gotta be careful. If they just stick together, they might break because they're so powerful, you know.
If they stick together from a distance, yeah, they can break.
Yeah.
By comparison to how strong those are, the ones that I got off Amazon that were sold to me as N48 ultra strong ring magnets with their little screw taper divot, which doesn't even match a standard screw, by the way. So worthless. Well, those things have about 1/12 the attraction force to the ones that Mark has sitting in front of him, but they're supposed to be the same physical volume and strength. 1/12. Big difference. Could you explain your apparatus to us, Mike?
Yeah, I got the working on the heat engine. So I got I water jetted the new cylinder. I took a chainsaw motor. I cut the bottom end out. So I got the crankshaft. I got the piston. I got all that there. And then I'm just, I put a special cement sealer to seal everything up. It can handle 5,200 PSI. So I've sealed it up. It's curing still right now. I'll be working on the top end probably tomorrow. And hopefully maybe by Sunday I might be able to fire it up for the first time. So what's unique about these heat engines is it could take any fuel source. It could be alcohol, it could be kerosene, it could be wood. It doesn't matter. That's the advantage of this little heat engine. It'll run off any heat source that you put on it. So I decided to make my own. water jetted the cylinder, and then I just bought a $50 set up chainsaw motor off Amazon and broke it down, cut the bottom end off it, and made my own cylinder. And there you go. All I have to do is put the top end on with the heat. And that's it. It's pretty much done. It's such a simple device. And then I've got the belt drive here. I'm going to hook it up to a little generator and see how much power I can get out of it.
Ah, very
So
cool.
that's, work in progress.
Well, now you get to use that heat engine for something else too that you didn't maybe originally plan on using it for, which would be plasma impulsion or plasma implosion.
I was just thinking about that this week. Yeah. And I have a device that I want to build in the next little while, which is going to add the plasmoids or the EVOs into the cylinder. So it's going to use a high voltage static discharge, go into a chamber where I'm going to have an ultrasonic fogger, make the fog, charge it with a high voltage static electricity, and then pump those plasmoids directly into the heat engine and see if I get any performance increase.
I just want to mention that don't use the 110 to 124 kilohertz mist makers that you can get for cheap. It turns out that the molecule size is so large, there's so much water in there, it can't distribute the charge correctly to equal breakdown, and you won't get the effects. You have to use the over 1 megahertz transducers that are designed for ultra-fine humidifier use. And you can get those in the form of what's called pond foggers, but if you get them in the form of mist makers, they're not going to produce the same effect too. So I've tried that and made that mistake before. Don't waste your time or money.
All right, so I'll have to look into that. How about the transducers that I use for the pulse motor? Can I mod those?
They're way too small, and they're not made of the right materials. In fact, go back and look at. Okay, so, sorry, go ahead.
The one I have is a 2-inch diameter. It's 41 kilohertz at 40 watts.
Do you know the chemistry? Is it strontium titanate or barium titanate?
Barium titanate.
Are you sure? So absolutely sure about that?
Yeah, that's what I had said in the description of it. Barium titanate.
I seen the description. I just wasn't sure if they had sold you a correct product. If it was and you were getting OU, it would have been in the form of the impulse, and you would have never seen it on your multimeters or on your cheap little watt meters that Gerald and both you are using.
Right.
They're actually ones I suggested to both of you guys, but unfortunately I have to kind of apologize for that because I later realized the conversions are completely invisible on the watt meters and on your very high-end, even something as high as a $600 Fluke plant meter or 5 series multimeter. You can't see the impulses, but they convert inside the battery in the electrolytic material. So as Bearden and Bedini had talked about, well, Bedini did his little speech, right? And he said they work in AGM lead acids, they work in liquid flooded cell lead acids, they work in gel cell lead acids, they work in large military lead acids, and they also work in diesel stack cell lead acids. So you have these many options, but he noticed that it seems for some reason, and it could be the density, maybe this has to do with TP Brown, but lead happens to be particularly useful for this. So if you had not gotten excellent results, but just partially okay results previously, maybe switch over to any form whatsoever of a lead acid battery. Because that Char Tesla impulse, once it enters the battery, you'll not measure the current, you'll measure an extremely high voltage impulse, which seems to disappear into the cell. And then for some reason, the cell voltage starts to go up as if it's charging at 10 amps, except for what you measure from your meter and your scope seems to be less than a couple of milliamps. And then just in the course of a couple of minutes, maybe less than an hour, you've acquired what should have taken you 10 times more energy to charge that battery up to. And since batteries are indicated in terms of their quantitative charge by their across the 6-cell junction voltage, you'll have so much more energy than you're supposed to have. So you discharge it, bring it down, and charge another one, and just jump back and forth, hence Tesla switch. which you've already played with and already have one sitting around. Use the batteries as your conversion mechanism. Forget about capacitors, supercaps. We've tried. They just don't work as well. I don't think that carbon is quite as suitable. But there seems to be something in the heavier isotopes. And maybe lead might work better, but I have a feeling that lead is just the beginning of these iceberg, that things with very, very high spin and odd nuclei isotopic ratios will actually be the solution to producing these higher spin states. Bismuth, for example, is already a great catalyst. Manganese, mercury. I mean, you could just, the list goes on. Just take a look at your spin isotope chart. But try it. You got to try it at least once if you're going to try and convert this energy, because it doesn't happen directly in the form of electromagnetic energy. This is in another form entirely, and this is where Bedini, I believe, with the Karma generator produced its whole output.
Did we lose him?
Nope. I think still. Oh, muted? Jeremiah, you muted.
I may have just overwhelmed, perhaps not lost. I have done that before, and I apologize.
I brought the materials over for the magnet spinner, at least some of them.
Awesome.
Bernie, you want to
take a look? Yeah.
So this is the little magnets I was telling you about. This little magnet, which is about yay big, size of my pinky, maybe a little bit bigger, quarter by half, can lift 25 pounds. That is very impressive for a magnet this small.
What? That's 20, really?
This is a 25-pound pole magnet, yes.
Can you like feel the magnetism force in your finger almost? Is that like it's so strong?
Not really.
Not really.
It's about a half a Tesla. So it's at a higher magnetic field than what we're doing some of the EPR experiments at. But that's only right at the surface. Of course, the field dies off very quickly with this. So what we're doing is we're sticking these, a bunch of them in a circle. This is going to be cut up, and this is going to go onto this massive motor over here with the motor controller, and it's going to rotate around very rapidly, and that will create thrust somehow. Here's a larger one to make a bigger one, bigger version of the same thing. Jeremiah, you want to explain how this makes thrust? Basically the Harold Tavares drive concept.
There we go. Yeah, I recently installed this thing that Gerald suggested on my computer, which allows me to watch YouTube videos at many times the maximum 1.5x speed. But it's now affecting StreamYard, so it seems like I have to get this pinned up on my Chrome tabs here and shut it off because it's affecting me from unmuting myself. Yes, I'd love to. So Tavares discovered an orthogonal magnetic field interaction that was actually in the mathematics from Maxwell almost 2 millennia ago. And between these orthogonal magnetic field interactions, both affect something fundamental that was not yet known in space-time, but now we recognize as mu. It's a spin in what's known as the J-curl vector. So if you create a torsion in the J-curl vector, it affects the velocity c, which means that the fields, in terms of how they interact with each other in different frames of reference, change the velocity of light in their projection of their of motion, or in that direction, that field vector. And we end up with the possibility of developing an interaction between two different frames that produce an unbalanced, non-Newtonian third law violating force. This is precisely what we're going to be doing. Now, there are several patent applications. I will not be sharing them here until they actually reach patent approval status, but just know that he's worked really hard on this, and the reason for why is, as Mark and I have found out the hard way after starting APEC, by giving everybody a free rein to share their ideas, it revolutionized the entire community, but it also had an unfortunate side effect, which was a lot of patent trolls that like to take other people's ideas came on and were quite proud of the fact that they were going to take your idea, if they could understand it well enough, patent it for themselves, and then do nothing with it, except for perhaps the possibility of selling it to some military contract. So, prior to this actually getting out in the full genre, we have to keep some things quiet. Nevertheless, full demos and visual representations can be had, just not the mathematics and the modeling. But you will be able to replicate this long before the patents pass approval process. Anybody can. In fact, it may be the simplest drive we've ever seen, and perhaps one of the most powerful compared to the available materials of today.
I've built a similar device based off of Amy Eskridge's dad's paper, Richard Eskridge, with rotating magnets, and that actually worked. And I did it. I ran the experiment live on Jeremy's channel right after the SETI conference when they were talking about UFOs. Burnt out the motor, but before we burnt out the motor, it was there was a positive result. It was bouncing a bit, but there was more weight on one side of the graph than the other. I do want to get rid of all the digital scales for this process, Jeremiah, and I want to
absolutely analog all the way.
It needs to be some sort of analog scale. An analog scale, by the way, works on Planck time. It averages on Planck time, so there's no higher refresh rate than Planck time.
If I could draw or animate for everyone what happens on the Planck scale as a result of these orthogonal magnetic field interactions under extremely small proximity at very high energy density, I would love to show that. But I have to work with somebody who's just phenomenal at 3D modeling and can understand the speaking words of a crazy person, which would be me.
I think I could find somebody like that over here who can do it. We have a computer here that has a pretty powerful GPU and some pretty powerful animation software. We could probably put something together like that here. Yeah,
that would be really something, because this would be so much easier to understand to people who just see the visual representation of it. For me, it's right there in my head, but there's no way for me to translate that because it's dynamic and moving and actually extraordinarily complicated, involving layers of energy density and magnetic field fluxes interacting at different angles. It tends to become very difficult. I guess the question would be, how can we represent the different rate flows of time in a three-dimensional graphic?
What about spin shedding? Isn't that a possibility of how this Tavares devices works? Like similar to how if you have a Helmholtz resonator and you vibrate it from the outside, by spin shedding, by vortex shedding, you're actually able to move it through space-time, through the air. Let's say if it's got vortexes of air, the vortices come out. Even so with this type of device, you have basically a chamber that's puffing air in and out, but it's able to move in one direction. The reason for that is because it creates a vortex that it pushes more air outside of it. You know, like the air that comes out is rotating, and that pushes more air in the opposite direction. But the same concept can apply to a magnetic field. If you get rotating magnetic fields, you can do the same thing. And that would be a true propellantless propulsion drive.
I like the idea of spin shedding because the technical term for what we would like this to be called would follow Dave Vissant Corporation terminology of a spin wave in the form of a radiation of that spin wave, meaning that it's transmitted out. It's not an electric wave. It's not a magnetic field. It is not an electromagnetic transverse wave. It's something different entirely called a spin wave. And it is actually the precession in time at an exact frequency for matching molecular energy densities of surrounding matter and on a localized space-time vacuum refractive index. He talks about this on his site, Vissant Corporation, but it's very seldom understood as far as a concept, and unfortunately, he freely admits he's not exactly the best at presenting it, and, well, I'm doing my best to try and present it, but even still, this subject is so new and complicated, we don't have simplified words yet, but we have to have them, and this will never be a thing if we don't find them. Can a
Should
fifth
we
grader
have a
understand this? No.
conversation with AI about it and see if it can frame it in the correct words?
We have, but we're getting there still. I'm not quite set up for it yet. But Mark did show me the other day using our proprietary AI.
That physics GPT-4 or whatever. That's epic stuff.
We did a private inquiry just offline, and holy shit, kind of blew my mind. Actually, it did blow my mind. Shouldn't say kind of.
Interesting.
Yeah, but keep in mind that AI is trained on the mainstream. If you ask questions that goes against the mainstream, it won't be able to help you out.
Well, yeah, that's the whole point, is putting in and entering in full data sets with the AI and like creating a full like AI set with the alternative data and information so that it can then be used for modeling in the overall grander systems.
So Mark typed in a very simplified prompt, which was a kind of a long run-on sentence, but really wasn't all that complicated. It delivered in less than 30 seconds after him hitting enter what took us, myself and Terran Earthling, who happens to be watching this stream right now, several years to accumulate. It just simply pulled them up in a matter of moments.
Yeah, a couple ways of creating propulsion. By the way, the word that Amy used, the word spin coupled field, to explain this force.
Sound familiar, anyone?
Spin coupled field, or spin coupled force. Magnetism is a spin coupled force. Spin orientation of valence electrons.
Synchronization of spin states. The same damn thing as quantum coupling, Cooper pairing, and all the other phenomena that we know and love.
Yeah, I think within spin you'd find all your other dimensions that string theory tries to invent. It's all in spin.
I think you're dead on right with that. It's kind of funny because back in the day, Bearden had made the mistake of speaking about an electron-filled universe, not recognizing the positron pair side of the entire equation. And I actually made fun of you a little bit in person, privately, about the concept of an electron-filled universe, also having been in disagreement with what Bearden said in that impromptu interview. But if we recognize both sides of the entire equation, it turns out that there is a free space filled with physical matter, electron-positron pairs in the form known as positronium at the finest scale, the Planck scale, all locked in and interrelated to themselves through their field position and dipole moment at something also recognized as the cosmic lattice. You could come up with a different name for it, but at that point, we still have something that's deeper in scale than the lattice itself, something even smaller than the Planck scale, that maintains the distance of the Planck scale, and this is the big question that science has yet to answer. We cannot explain what is beneath the Planck scale, or what allows the Planck distance to remain something that's closest to the constants of all the constants we've ever tried to give names to. Gravitational constant, cosmological constant, K factor, epsilon mu, keep on going.
Isn't that what we have DMT for? To find what's below the Planck's constant?
I was hoping you might mention that, and you're dead on right with that. And that's exactly, I think, why we naturally have this in our minds. Or should we ever dare adventure outside of our minds?
Oh my God, Jeremy's here. Spin coupled. No, the spin coupled force was was her secret sauce. And actually, her dad wrote a paper about it. And this rotating magnet thing that Jeremiah is coming here to try out is extremely similar to what she's talking about. I mean, the only thing you'd have to do differently is point it at the North Star.
Well, we better do that then.
Oh, we definitely will. I have the North Star actually lined up. I have like lines written on the Faraday cage to point toward it.
Can I say that I take no responsibility if this thing blasts right through the side of the Faraday cage and right off the top of the cement building?
No, it won't do that. More likely, it would fall apart and crack stuff. I'll have a whole by rotating magnets real fast.
Oh, come on.
Actually, I think doing this inside the Faraday cage is probably the safest way to do it, because the Faraday cage is pretty well built. It won't, if a magnet falls off, it won't hit us.
Precisely what I was thinking. Before we do the shielding, we'll have a chance to balance it inside that thing where we don't all die.
Yeah, I think we'll just do it inside the Faraday cage. That would be so much easier.
It should work there too. There's if this is truly a space drive, our spacecraft will indeed be basically a Faraday cage. So it had better work inside there.
Yeah, Jeremy, she didn't know I was into Alzaphon. That's why one of the reasons why she was so interested in it. And when she introduced me to her dad, she actually talked about the Alzaphon experiment and told him that, I was into it before we met. And it turns out Daniel Alzaphon, David's brother, was actually at the Eskridge house and worked with Hathaway with the machine we have literally right over there, trying to replicate this experiment. And the book that he was carrying around, the Dynamic Nuclear Orientation by C.D. Jeffries, that was the book that literally fell off the shelf when Frederick Alzaphon was in a library trying to figure out how flying saucers worked.
Dude, it's like Interstellar or something.
Yes, yeah. Reminds me of Interstellar. How like the energy from the soul came back from the other side of the wormhole and pushed the book off the shelf.
That's so awesome.
And it really is the holy grail for dynamic nuclear polarization, in terms of methods, how to do it, the math, the science, everything behind it. There's no other book that comes close to the breadth and depth of scientific knowledge on this specific subject. And it was published in 1963. Think about that. 1963. That's how old it is.
We should look at the superfields too, because past 1963, the golden age from the 1960s to the 1970s, the golden age of electrogravity and all the major discoveries that happened, including Thomas Townsend Brown and the many other names that most of this community knows. We had other researchers that came into the picture, folks like Mike Wendell, Warren York, Andy McQuarrie. Now, these guys had done incredible things, and they worked with that group that has been recognized as the Colfi Conference, which was started by, please don't tell me I'm the only one that can say this name. You know who Colfi Conference was started by, right, Mike?
Mike Gamble, or the guy from DC. What was his name? He's in charge of it now. He wrote a whole bunch of books and refused to come to the lab.
Well, you can't blame him.
I'm loving it. Loving all of what you guys got going on and working together again, coming back.
Tom Vallone did a great job and organized most of this. Tom Vallone was early on sort of character, much like our modern hero, Tim Ventura.
Tom Vallone goes a lot farther than that. Tim Ventura did it as a hobby. Tom Vallone does it for a living, and he slaves away to make it happen. So my hat's off to Tom Vallone. I really wanted to meet him in person. He's always busy doing some fundraiser or he's trying to sell some Tesla chairs in order to help the research happen. I'm not really sure what exactly it is he's doing, but he works in this alternative energy, alternative propulsion field and tries to make a living off of it by selling end user products that he makes himself, handmade Tesla chair.
If you look at what he drives around, he's not exactly making a huge living or extracting a huge amount of this for himself. He takes the minimum to to provide his own personal necessities, and then beyond that, it's pretty much coordination. I thought that he had major health issues at this point, and unfortunately, we lost Bearden, we lost McCandlish, we lost Bearden and his brother. We lost Bedini, we lost Beard and we lost Bedini and his brother. We lost most of the people that were involved in the alternative energy research community. And the funny thing is, I know that we started a conference about propulsion, but when you get the energy, you also get the propulsion. They're almost inseparable because both of them operate on the modifications of the local refractive index. Hence, this is where you get your warp drive concept from. There's just no way to get around it. But they're all on now.
I've heard that, and when you shut it off, the force doesn't go away immediately.
No, and it's linked to the localized environment, meaning if you move your drive or your device, it doesn't do the same thing until you repolarize a new area.
Also, Mark McCandlish and Paul Violette have all passed away as well.
Oh, the Violette, definitely a very good name to mention.
And we got them on
legend and pillar.
That's really cool. Oh, by the way, hats off to your new lab coat. I haven't seen it yet, but if you want, we have patches that you can put on it too for APAC or Falcon Space, whatever you like.
Oh, I'd like to put APAC on there perhaps, but I was thinking, slamming it with an exotic propulsion. I just have to send it there. They take a little too long to ship.
Do you have an exotic propulsion logo?
Just a couple of pieces of text.
Okay, I actually can. I can make something on the Cree-Cut, but I can't do something like it as nice as your logo. I could make a iron-on patch on the Cree-Cut machine. You could decide if you want to use that.
If it sticks for a week, it'll be good enough for me.
I don't wear.
I'm just having my embroidery machine.
I have not worn a lab coat in so long, actually. To be honest with you.
Well, when we go to show this, it might be something fun.
Yeah, it'll be fun. I haven't put on a lab coat in a while. It definitely makes things exciting.
Yeah, since we already know this works,
Real science.
At this point, it's just about really showing people something very fascinating and interesting. And so, if the rather innocuous part of this show or demo happens to involve lab coats, then so be it. Of course, we don't need them because it works on its own. It already is, but it seems very garage inventor, and we might as well throw something on.
Well, I do have a bottle of champagne that's been sitting in that fridge for years. And if it works and we see significant positive energy, positive thrust that is, way out of the, the vibrations and the noise floor, we're going to pop that open.
Hell yeah, we will. Well, intend to have that thing ready to go.
All right.
Yep.
All right, I'll let you guys do because I got to do an experiment by midnight. So
later. I'm going to mute myself and.
Fair enough. Excellent episode. Thank you all. I look forward to seeing all of your guys' real science happening and developing in the next experiments, and we'll catch you at APEC or back here again next week. And shout out to everybody in the chat.
Before we end this, I'm sorry, I should have said this earlier. I didn't mean to disrupt. But I'm going to stick around for just 20 minutes after the show if anybody had any questions about these space drives. And I want to keep it focused on that. But just that, if nobody does within the first couple of minutes, then I'm jumping off. But please do post that link, and then we're out of here.
Fair enough. Post in the StreamYard link if you've got questions for Jeremiah on the space drive. Then come on in, and we will see you all on the next one. And thank you, Gnostic, for joining us. And we will have Gnostic back for a full podcast going into, Gnostic topics, esoterics, and the science of sound. And we'll see you then.